Let's have a go at the next question. We have two balls, X and Y, which move along a horizontal frictionless surface as illustrated in the figure 3.1. So ball X has an initial velocity of 3 meters per second. So the initial velocity U1, let's call UX, is 3 meters per second in a direction along the line AB. So the direction of the velocity is also given. Ball Y has a mass of 2.5 kg. So we have mass M of ball Y, which is 2.5 kilogram. And the initial velocity is 9.6 meter per second. So initial velocity, let's call it Uy, is 9.6 meter per second. So here we already understand that this is a question which involves two-dimensional collision. So we will have to resolve the vectors, that is the velocities, into their components. Moving ahead, the two balls collide at point B. This is the point of collision or point of impact. The balls stick together and then travel along the horizontal surface in the direction at right angles to the line AB as shown. So here we have their velocities, which appears to seem that they only have their perpendicular or vertical component of velocities involved, whereas the horizontal component of velocities are nullified after the collision. By considering the components of momentum in the direction from A to B, show that ball X has a mass of 4 kilogram. Here, as I told before, we will have to resolve the vectors into components. We understand that the angle of projection for ball Y is 60 degrees with respect to the horizontal, which means its horizontal component of velocity is going to be negative. We take negative because it is in the negative x direction. Negative 9.6 into cosine of 60. Let me read this. So the horizontal component is negative 9.6 into cosine of 60. This is the horizontal component, whereas its vertical component can be assumed to be positive 9.6 into sine 60. So this is the resolution of a vector into its components. We know that ball X is projected horizontally, which means its vertical component is just 0. So we understand from conservation of momentum that whenever there is a collision involved, as such explained in the question, the change in momentum is 0, or total momentum before the collision is always equal to total momentum after the collision. So in other words, so the mass of ball X is unknown. So let's assume it as a variable M. So M times its horizontal component of velocity 3 minus, the reason we're writing minus again is because ball Y has a horizontal component which is in the negative x direction, and hence assume negative. So negative 2.5, which is its mass, into its velocity. Since momentum P is defined as mass times velocity, we are multiplying mass and velocity for both the bodies into its horizontal component 9.6 into cosine of 60. This should be equal to the horizontal component of momentum after the collision. After the collision, we understand that they are projected vertically, which means horizontally, either of their velocities are 0 or the entire momentum is 0. And here, everything is a known value or a constant except M. And when simplified, we get the value of M to be exactly equivalent to 4 kilogram as asked in the question. Moving on to the next part. Calculate the common speed V of the two balls after the collision. To get the answer for part A, we equated the momentum before and after collision horizontally. So to solve part B of the question, we are going to equate the momentum before and after the collision vertically. So ball X did not have a vertical component as stated here. So the momentum of ball X was initially 0. This in addition with the momentum of ball Y horizontally was M, which is now known to be 4. So let's substitute 4. 4 into, I'm sorry, I think that's 2.5, my mistake. 2.5 into 9.6 into sine 60. 9.6 into sine of 60. This is the total momentum before collision. This is equated to total momentum after collision. We understand that the bodies stick together after collision, which means their combined mass is 4 plus 2.5 times the final velocity along the vertical direction v. Here, as usual, everything is a known value except v, and when simplified and written in terms of v, we get the value of v to be 3.2 meter per second. Moving on to the last part, determine the difference between the initial energy of ball X and the initial kinetic energy of ball Y. So we know that kinetic energy Ke is given by the formula half m times v square. And since kinetic energy is a scalar, we do not need to resolve vectors into components. We can directly take the value of the complete vector, which is 3 and 9.6 in this case. So the difference in kinetic energy delta K is just equal to half into 2.5 into 9.6 the whole square minus half into 4 into 3 the whole square. So when simplified, we get the difference in kinetic energy to be 97 joules.